Hello everyone. Today we are going to see how we can design a large-scale photo short form video sharing system. Um, this is a very classic question. You can see it in other forms like, hey, design Instagram, design TikTok, something like that. This can get very complex, and even with simple requirements, a lot of people, even experienced people, they make mistakes. So let's see how we can build a system. Okay, so this is the prompt given to you during the interview. So at the beginning of the interview, just take a look and see if we have any follow questions. Okay, so user can post images and videos. Good. We already mentioned that the prompt says short form video, so we can probably ask what short form means, and they might say something like, okay, let's just say 2 minute max. Okay, so that's fine. You can clarify. Users can follow people. We can ask if there is any maximum number of followers. Interview might say no, there is nothing like that. Users can engage with posts. You can ask here, okay, what do we mean by engagement here? The interviewer might clarify something like, okay, let's just say users can like video and maybe add comments. That's all. Okay, so engage, we just clarify here, like and comment. That's good. And user can see a feed of posts when they visit app home. Okay, this is good. You can ask, how do we want to show this feed of posts? Like, is there any specific basic requirements? And the interview might say, um, uh, I mean, they might say something very simple like, okay, just give it based on the post time recency. But really, gone are the days. Nobody says that anymore. They actually, even for non machine learning, regular software engineering interview, they want a little bit of smartness because we are in AI era. So even if you are not an ML engineer, they expect you to add some smartness to it. So they might say based on relevancy or based on virality or something like that. Okay, so you clarify these questions. So here they can just say something like basic smartness. So it's not just based on just the recency. Okay, so we'll figure out how we can achieve that. Okay, uh, now let's get into any non-functional requirements that we might have. Uh, if they usually say something like Instagram, you don't have to waste much time, but just quickly write down things. We are thinking of scale as in 1 billion users. They might say, and at any given point of time, 100 million plus active users. That's a big scale, right? And even if you assume that one post for these active users, then we are talking hundreds of millions of posts every day. So we can just talk about that, quickly mention, and then you can say that we want the system to be highly available. That's good. Eventual consistency is okay. And again, this is just for post feed generation. For anything like auth rate limiting, we want full consistency, strong consistency, but we are focusing only on the functional side here. And then you can say probably bring it up latency wise, and the interviewer will definitely say we want a very short latency, as less as possible when user try to look at the feed. So we'll say latency in say something 500 milliseconds, less than 500 milliseconds if possible. Okay. um, I see one major problem that a lot of people get into. Right after this, they'd start going into the tabular calculation, like, okay, so let's assume that one image is 1 MB on average, and then into 100 million plus MB equals, we need, you don't really need to do that. We all know that this is a mega scale system, so you just need exabytes, so you don't even have to get to do that. Okay, so nobody really wants, if you spend time there, I guarantee you're not gonna clear the interview. Okay, so just move on. Okay, we know that it's a very big scale system. Okay, So quickly talk about entities. Let's just go. I always say start from whatever we have here. So we have users. That's good. We have posts. That's good. Post metadata. You can call it like post metadata. We'll just like call it post for now. And then we can have follow information. Then we can have likes, comments, and that's all for now. So pretty good. Users will have all of the user related information. Metadata. Post will be like the post related information, and also like the links to the media, images and videos. Follow, who follows who and what timestamp. Like again, it would be simply post id and the user id and maybe timestamp. For now we're just like simply taking it. Like maybe if in the future they might want to say, okay, I can react, but for this problem we'll just like say like and comments, simple comments. There is no nested comments or replies. Okay, so we are good here. Let's directly get to the system. Okay, right. So first, users can post images and videos, and so we can at the beginning we'll start with like the system, and then as we build the systems we can decide how the systems talk to each other. Okay, so we'll start with the client app. And this could be iOS, Android, anything that future comes. And as usual, we just like put a gateway here. The gateway will take care of everything for us, like rate limiting, authentication, routing, experimentation, logging, anything else you want to add here, the gateway will take care. And so we can just like simply focus on the services. And here we first start with a post service. Okay, so this will take care of all the posts for me. Okay, so how would this go? My client would make a post, and the post service would just like do some quick validation, and then let's add a db here. And it writes to the db, and then it gives acknowledgement that the post is being added to the system. Okay, so this is high level. Okay, but we are discussing media here. So how would it work exactly? I mean, you can say that, okay, the client directly uploads the images and videos to the post service, which then adds the metadata to the db. And then in order to keep the images, we can say that, okay, I'm adding another system. For simplicity's sake, we'll just like go with s3, and then it stores the images, post images here. So this one would be like post metadata, and this would be post media. Okay, images. So you can say that you directly upload to the post service adds the metadata to this db, and then adds the images to s3, and then acknowledges. But this is not gonna scale. But for now you can simply say this is how you're gonna handle, and that's fine. But clearly tell the interviewer that this is going to add a lot of strain to the post service. So we'll come back and fix it. Okay, so the next one would be let's call it like a simple follow service. It's going to be a lightweight service, actually post can handle. But as principle, we'll just like try to like keep our services as micro as possible, and everything will be just like doing only one simple stuff, so we don't really have to worry much. um, we can scale as necessary. Okay, so we will just like say, hey, for follow service, user would send a request, and we would just like add we can have a separate db here, just the follow db. And we will have, and as for like the db types, it really doesn't matter. You can simply say for now, for our case, I mean, in real world, Instagram or TikTok or any other social services that would they would when you request a follow, it would just like go as maybe like let's say SQL here. So here it would just like simply go something like, follow, follower, followee, and timestamp it. This is how it would go. But this is not going to be enough for most of the sophisticated algorithms, so it would build a graph based on that. But for our simple case, we'll just say, hey, I'm gonna have a simple DB. It can be Postgres, SQL, so you can like query up. You can also say I'm choosing a NoSQL like DynamoDB and say that okay, the follower would be actually it would be easier if it's this way. It really doesn't matter much, both has its own pros and cons, but we'll just like for now we'll say followee is like the partition key, and follower you can like add like a secondary index, global secondary index. So that way you can like for any followee you can say all the followers, and for any follower you can say all the followee. So that's it. All it does is it adds an entry that this user user A follows user B, and that's it. Okay, cool. And then for engagement, like your user can like and comment, so we'll add a new service. We'll call it engagement service, and it just gets from the user. And so it would be something like for engagement service you can like have a separate post call. All it does is like the post ID, the user ID, we can get from the gateway. So we just like need the post ID, and either it's a like or it's a comment, and then in both the stuff it does go and write it to a separate DB here. This can all be in the same DB, so we can just like for now we don't really have to go make things real complex. We'll just like say it writes to the DB. This one DB has post metadata, and then it also has like information, and it also has comment. And as for comment, all we can do is like post ID, user ID who's commenting, comment data, and timestamp. That's it. I'm going to click enter, so it's okay, cool. Okay, and for like it's much easier. Post ID and user ID, that's the only thing we need. Okay, and for notation it's good if we just like stick with one. It doesn't really matter much, but okay, so we have the engagement service all done, and then finally all we need to do is like a feed service. Okay, so we will have a feed service here. So we will say that okay, whenever the user loads the page, the feed service, what it would do is it has the user information, so it just goes and fetches from the follow DB, hey, for this particular user give me all of the users this user follows. Okay, so let's say this is Postgres, so it would just like give you the list of all of the followee IDs, and then you go to the post DB and say okay, for this user or for the list of this user, you can just like all you have to do is like iterate through all of the list and say for this user give me all the post. Let's say just like we stick with 10 post, and we just like get all of these posts for all of these users, and then we kind of like stitch them and return to the user. As I am talking, you can see that wow, this solution really doesn't scale. This doesn't really make much sense, right? So you can actually mention that. In fact, I would advise that you don't even have to play dumb here. I mean, your interviewer is smart, you are smart, you don't really have to suggest this solution and say I'm going to read from this. No, you don't really have to say that. All you have to do is like okay, I'm going to have a feed service. My feed service would directly read from not from that DB, but from a pre-computed feed service. Like, so you will just say that okay, so pre-computed feeds. Okay, you just write from the pre-computed read from the pre-computed feeds, and then you respond um, the user back with the response. So okay, now I think we have the high level system. Now we have to go deep dive. So we will talk about all of the things from the non-functional, but also we left some pieces like unfinished in from the original design. So we can talk about that. So starting from the very last one, we said we'll have a pre-computed feeds, and the feed service will directly read from the pre-computed feeds, and then we can respond return to this, right? So let's talk about this. And this is a very meaty problem, and as you can see here, we also wanted some basic smartness. So this is probably the place where you want to spend a lot of time. Okay, so we will talk about that. Okay, so some of you may know this, but some of you who don't know, I'm just gonna explain it anyway. So I'm gonna talk about the two major approaches here: the fan out on read and fan out on write. So what happens is, so in real life, like any big social networking site, like Facebook, Instagram, LinkedIn, none of these systems, they compute feeds when you are querying. You pretty much know this, right? So you know this. So they do it when the user write. So because it's a trade-off. You either do it upfront, so the latency while loading feed is really really minimal, or you do it like during the load time, so the latency is like pretty bad. So any company would optimize for the first one. So let's see how that works. So you write a post. So when a user writes a post, we would directly, so we'd first persist it, and then what we would do is we would write it to a queue. So we can, let's say we just add uh, you know a, a queue here. So we'll just go with a Kafka. So all it does is it stores the I post, and then it just enters the post ID here. Okay, it just enters the post ID, and there is no topic necessary. We'll just have only one topic. That's totally fine. And then we'll have some worker here, so we'll call them fan out workers. So what these fan out workers do is there'll be multiple workers, so they just pick from Kafka. They pick the post ID, and the post ID now will have all the information, right? So mainly the who the poster is, so we know who posted it. So now we go to this fan out worker, go to the follow DB and say, hey, give me all the followers for this particular user. And then it has a list of all of the followers, and then it would go and write to, we can sort of call it an inbox. For all of these users, we'll have an inbox in the pre-computed feeds. So let's say user A inbox, he will have a list of all the post IDs: post 1, post 5, post 20, things like that. So we'll just have all the post IDs here. So when a new post comes, let's call it the post 100, right? The fan out worker would look up the follower DB, and it finds who the follower is. And if user A is a follower of this particular poster, then it would, let's add this one here. Let's make it maybe a little bit like this. So okay, so then it just directly adds to the inbox of this user. So that way, when the next time user A comes, the feed service would just directly go. So how does it do? It, for now, for simplicity's sake, we'll just say the post 100 is added here. Then the user A, it just looks for the user A, and then it gets all the post, and then it just responds. Okay, good. So this works for regular poster, a user who makes this post. But what about celebrities, right? So that's the celebrity hotkey problem. So sometimes you may have uh, celebrities posting a lot of stuff. Not sometimes, all the times the celebrities post images, photos, videos, everything, right? So say a celebrity has like 100 million followers. That's very common these days. Now this fanout worker have to go and add to 100 million inboxes, and that's not going to scale. That's just like going to like really exhaust the fanout workers. So what we can do is we will just have two sets of logic. First one is, say, I mean there is no real number here, but we can say if a user has, say, less than 100k followers. There is again like no real number, and in fact like uh, in reality, like these numbers would be determined by maybe just the machines. So the machine might say, okay, let's increase the threshold to like a million or something like that. If the user has 100 less than 100k followers, then write to user inbox. Okay, if the user has more than 100k, then they come under celebrities. So what we will do is we will have another pre-computed feed. So this is what we call pre-computed. So we'll just like add one more here, and here. Okay, so here we will call it celebrity posts. Okay, so the fan out worker would just write to the celebrity worker here. If the user has more than 100k followers, then we just write to the celebrity post db. It's usually like a cache. It's not db, so we can like say, okay, for our case we'll just like say we choose redis here. So if the user has less than 100k followers, then we write to every single followers inbox, and if the user has more than that, then we just like write to the celebrity post. And how would the feed service work? The feed service would actually compile from both the list, right? So it would get from the pre-computed feeds, and it would get from the celebrity for the users who are like, it would just like first it would get from the pre-computed feeds, and then it would go get, hey, give me all the followers for give me all the users this user follows who are celebrities. So we need to add something here, like say a follower or some other user way where we just like quickly filter by just the celebrity followers. That's easy. We can like make some smaller changes here, and we'll just like say the follower is a celebrity, sorry, the followee is a celebrity. So then we just go to the celebrity, and then here we will have like a separate inbox like this, celeb a, they'll have some recent post like post 23 post. In reality the IDs would be like very complex, but just like for the sake of simplicity we'll just like say celeb A has 2 posts, and celeb B will have some other post, and so on. Celebrity B will have 2 posts, post 53, 52, and post 90, something like this. So that way now it would just like go for, we'll have this for all of the celebrities, and we just like pick the celebrities that the user follows, and we'll just like combine both. We'll again only have the IDs here, right? So we'll combine both, and we will just return with the pagination. Okay, so at the high level now we have a hybrid solution. We will do fan out for all of the users. It's technically not hybrid. It's not like a fan out on read. It's both. It's fan out on write, but the hybrid as in we write to the user inbox, and we also write kind of like as an outbox. So you can treat this as inbox, and you can treat this as outbox. So we mix both during the feed service, and then we send, right? So that's how we do. Okay, cool. Now let's talk about some basic smartness, right? So this is how here this so far this is fine. This is kind of like knife. You will just like we just assume that the fan out workers would write and then always add it to the very first one. We'll just like say for any user we'll only keep like 50 posts or 100 posts. Anything after that, we can probably take a snapshot and put to S3, or we can just like, for I would say how Instagram does is like it just like keeps like up to like 100 posts in your inbox in the Redis. And it also has like some in the S3, but otherwise, other than that, as you are exhausting, it just like does more computation, so you'll never run out. Okay, so you can say that's a hybrid approach we're going to go with. So we'll just like say pre-computed feeds we want to like have up to like 50 to 100 for users. You can also like instead of having just one static number, you can say if it's a very regular user, then we'll just like gonna have like 100 or even 150 posts, because these users are very regular, and that means they'd easily exhaust all the posts, and we have to do more computation, and that's more cost for every single user. So we'll just like have a number defined, and if they exhaust more, as they're exhausting, we can like populate more feeds and then add it to the inbox. For celebrity post, it's fine, we can like have up to like again like 50 to 100 per celebrity depending on like how fast they go. Okay, so now how can we add some basic smartness here? So instead of like recency, they might want something like relevancy, right? I'm not gonna go super deep into this because it's not an easy problem. It is a very, very complex problem, and you cannot solve it without heavy machine learning algorithms. But what you can say here is you can you can start mentioning few abstractions, and that's what interviewer is looking for. You can say, hey, I'm going to have a black boxed ranking algorithm. So here we'll say a ranker service. Okay, this is an ML service, and we can call it like a black box. You don't really have to know what's in it here. What it does is you so the ranker service's job is to kind of rank the posts that are in the user. So it's not based on relevancy. So you can say it just like, you can have it both ways. You can say the pre-computed feeds come get written, and then you pass the set of feeds to the ranker service, or you can say this ranker workers, they keep on like working on a timely basis, and then just like come in updates. However it is, it's totally fine. You just like have to say, hey, I'm gonna have a ranker service, and this ranker service helps me rank the post based on lots of things, based on how recent the post is. Because if it's like 10 days older, probably it's, I mean, 10 days is like an exaggeration, but even 3 days, 2 days, the value goes down. And maybe high engagement post, that's probably gonna make the post a little bit like more relevant. You may have a lot of working done with the user, like you may engage a lot with the user, and so it does factor everything. So let's say factors lots of things. uh, Engagement between users, post virality, um, other things like timeline, lots of things. So all we are saying is we are having a ranker service that would rank every single post. So how can it look like this? So now instead of like simple set, we will go with something called Redis sorted set, and this is how it would look. We can say the rank's gonna be from somewhere from 10 to 1. Okay, so a 10 would be a highly relevant post. So say, okay, 10, these are the posts that are ranked to 10. And then you can say something like for 9, you will have some other post 4, post 3, post 29, something like that. Okay, so this is how the ranking works. So what's 10 today might get to downgraded to 9 or 8 tomorrow because it's older, and what 9 today might get bumped up to 10 because lots of people are engaging with the post. So this takes care of this. And now also what it does is, for some celebrities, you don't really follow all celebrities with the same passion. So maybe it also knows your so we can call it like users personalization, some data. It maintains some manage some data, users history or something. And then it also can rank celebrity post, and we are not adding this here, but it would take some so for example, when you are like looking for the feed service, it would get all of the posts in the celebrity post list. Say it collects like 100 posts, right? And then at that point of time, it can also rank those and keep a copy here. So that, how would that look? That would look something like this: user a celeb list, and it would have simply like 10. Again, ranking would be something like post 23, it's very popular, and post 52. And so it would do for, again, like for 9 it will have some post, for 8 it will have some post. It will do that. Okay, so when you request a feed, first the pre-computed feeds would take only the one from the 10 on both sides. It would mix both posts, and then it would give you back your list. And when you request more and more, it would go and fetch the next ones. So here's an interesting piece. The interviewer might ask, how do you go about it? How does the service know what you have served? And here's where many people struggle. We always simply say we do pagination, right? So paginated feed service. And here we always do something called many people say offset is like a very old one, so you know that. Some people say post id, and post id works only for very basic system. But the moment you start talking about relevancy or like smartness, post id doesn't really help. So instead, your cursor should be something that's very smart. So you can have any cursor, and let's say the cursor is called like we'll call it like an a, x, c, d, f, g. It doesn't matter. This is like just like the cursor. You will pass the cursor, and at a separate level, I will have this cursor stored. And for this cursor, what I would do is I would have the cursor name, and for this cursor, I would say I would store something like very, it could be very simple. I would store something like this: user post last served rank was say 10, and I can also store the ID here. So or like just like let's just like user post 10 and celeb post 9.8 or something like that. And it would also have a time to let's say valid until timestamp, so something like that. So when you send the cursor again, it knows exactly what the cursor served last, and it would check for the time. For example, you might request page after like 10 minutes, and this probably is no longer valid anymore, so it doesn't care. It just like sends you the top 10. Otherwise, if this is still valid, then it uses these as the bookmark, and then it would just like go and fetch further post, and then it would update the cursor. So the next time when you request, this cursor would again serve as a bookmark, and it will also update the timestamp. So this is how we do the feed service. And I think at this point we covered very deep at the feed service. We talked about like the fanout workers, we talked about hybrid inbox and outbox, and we talked about like a little bit of like smartness, where we just like don't serve by timeline, but also like based on some relevancy. And we also talked about like pagination. One other point I would probably want to like mention is we didn't talk much about post service. So how we can post the images is actually, this is how you should say. So we have heavy images, and heavy images, if it goes through post service, so the client uploads to post service and then post service uploads directly to S3, it's like two hops. So you don't really need to do that. So your client, this is how you should design the app. So in the client app, whenever you make a request for the post, you can say, hey, give me some so something called, let's say you have something called get request post. So you are just simply, you are not posting, but you are simply requesting to make a post. Your app would make this whenever you, the moment you click plus and you want to like upload an image, it would just do a request post, and the system would serve something called pre-signed URL. Okay, so this pre-signed URL is what you will use. This is going to be valid for like say 5 minutes or something, and then this is what your app will use to upload the image. So the next your app would do, once your app receives the pre-signed URL, what it would do next is, so before that, where this comes from is your post service talks to S3, and it gets the pre-signed URL and gives you back. So you have the pre-signed URL. Now your app, the interface would let you upload some photos, and then it would let you add some caption, hashtag, tag people, whatever you want to do, right? And then the moment you click post, it makes two calls. First one is to the pre-signed URL, and this pre-signed URL will, your app knows exactly how to chunk the image, and it would send the image metadata to this pre-signed URL, right? So it just like sends the media information, and sometimes it's just like send in one chunk if you have like multiple images or videos, or sometimes if your image is like too heavy, then your app is actually built with the logic to chunk the images, and then it would directly upload to the S3. Okay, so the image would directly go to the S3, and then it would make another post. So it makes two calls. The next post is something called create. Let's move it a little bit. And this would be to the post service. So create post, and it sends the other metadata like the caption, image metadata. So whatever, so media metadata, whatever you want to do. And also it can pass the pre-signed URL that you are using for posting the medias. So the post service would first go create a record, and then it would wait for S3 to give a signal. It uses the pre-signed URL, and it uses that, it actually has a reverse mapping of an ID, and it just like checks with the S3, and once the image is ready, then it gives a acknowledgement that yes, your post has been received. So that's how it would do. And then you can also like mention other things like, hey, you just post an image, but that's not just like gonna be there. You will have transcoders to compress the image, so there is a lot of people who can like view the videos for various different systems, various different phones of various different resolutions. And also you can quickly mention that you will have a CDN of some sort where you will fetch, you will cache, and for anyone else who's like requesting more information, you will just like directly go from the CDN. So for various geographies and for various network issues, you will just like adjust based on routing to the closest CDN, or the image that with the appropriate resolutions for the network. So yeah, I think we covered pretty much everything. For scaling, otherwise it's really not a big problem. We have all of these services can be scaled by adding more machines. If you use AWS or GCP, you can configure all of these things, and yeah, I think this is pretty good. So if you look at the feed service, this is where I would actually spend a lot of time, because like I said, I'm gonna repeat again, gone are the days where people just simply ask, give me a very simple feed service. So focus a lot on the feed service, and they might even like ask more questions around, instead of just like showing the people I follow, how would you build something like an explore or designed for you. Happy to like follow it up with another video. I'll stop here. Please ask any questions, or add any comments to the video, and if you really liked it, please share it with your fellow interview people who prepare for the interviews. Thank you.